Welcome to Educator.com. Today we're going to be talking about graphing and solving quadratic inequalities, and we're going to apply some techniques learned from linear inequalities in our work. So in order to graph quadratic inequalities, use the techniques learned for graphing linear inequalities. And recall that involves graphing the related equation and using a test point. Except this time we're going to be using a quadratic equation. For example, just starting out with something simple, if you had an inequality y is greater than x squared minus 2, the first step is to graph the related equation. In this case, the related equation is going to be y equals x squared minus 2. And that is going to give the boundary line for the solution set. So looking at this form, this is actually in vertex form. And here a is 1, h is 0, and k is negative 2. So what this tells me is that the vertex of my graph is at 0, negative 2. So I have the vertex at 0, negative 2 right here. And I also know that the a is positive, a is greater than 0. So I know that the parabola opens upward. So I have a general idea of the shape of this graph before I even get started. Now, to make a more exact graph, I'm going to find some points. And the first point is going to be negative 2. Squared is 4 minus 2 is 2. Negative 1 squared is 1 minus 2 is negative 1. And then I already have 0, negative 2. This is my vertex. 1 squared is 1 minus 2 is negative 1. And now 2 squared is 4 minus 2 is 2. So this is enough for me to go ahead and graph. So negative 2, 2. Negative 1, negative 1. Vertex, I already have graphed. 1. Actually, this goes negative 1 is right there. And then 1, negative 1, 2, 2. So I can see the shape of the graph. Now, since this is a strict inequality, the boundary line is going to be dashed. It's not going to be part of the solution set. And as expected, this parabola faces upward. Okay, so just as with linear inequalities, my first step is to graph the related equation. My second step is to use a test point. And recall that a good test point to use is, I'm going to use the test point 0, 0. Because it's not near the boundary line and it's a very easy point to use. So I'm going to substitute 0, 0 into this inequality. Y is greater than x squared minus 2. So 0 is greater than 0 squared minus 2. So 0 is greater than negative 2. And that is true. Since this is true, this test point is part of the solution set. Now, the boundary line divides this into two sections. The area inside the parabola here and the area outside the parabola. And what the test point tells me is that since the test point's inside the parabola, the solution set for the inequality is also inside the parabola. If this had turned out to be not true and the test point wasn't part of the solution set, then the solution set would have been out here. Okay. So that was graphing quadratic inequalities. Now, we're going to talk about actually solving quadratic inequalities. In this case, we're going to, again, graph the related quadratic function, but then we're going to find the roots of the related quadratic equation. So we're looking for something slightly different. Remember, what I just looked at was this, where I just had y is greater than some function. Okay, now this time I'm actually going to say something like x squared plus x minus 6 is greater than or equal to 0. So I actually have a number here. I have a parameter. I'm saying that this function value is greater than or equal to a specific value. So I'm going to start out by actually finding the roots. Because by finding the roots, my graphing will be easier. Because recall that the roots give me the x-intercept. Okay. So let's write the related quadratic. Let's go ahead and find the roots by writing this as a quadratic equation. And looking at this, as you know, there's many different ways to solve quadratic equations. In this case, factoring would be an easy way. So I can see that I have a negative here, so I have x plus something and x minus something. And I also know that my middle term is x, so I have to look at factors of 6, which are 1 and 6 and 2 and 3, and look for a combination here that'll add up to 1x. And it actually turns out to be x plus 3, x minus 2, because that would give me negative 2x plus 3x to give me x for the middle term. So I did my factoring, and then using the zero product property, I know that x plus 3 equals 0 and x minus 2 equals 0. So this gives me x equals negative 3 and x equals 2. So those are my roots. X equals negative 3, and it can also equal 2. That means that my x-intercepts are at negative 3. So this is negative 3 and 2. Those are the roots. Okay. The next thing I'm going to do in order to have my graph is to find the vertex. And recall that the vertex equals negative b over 2a. The x point, the x value for the vertex equals negative b over 2a. So here I have b is 1. So this is negative 1. A is also 1. So this is going to give me negative 1/2. So at the vertex, x equals negative 1/2. In order to find y, the y value, I'm going to substitute in, and I'm going to find out that I'm going to get negative 1/2 squared plus 1/2 minus 6. Okay. So I need to solve this to get my y value. And this is going to give me 1/2. This is actually negative 1/2 right here. 1/2 squared is going to give me 1/4 minus 1/2 minus 6, which equals negative 1/4 minus 6, which equals negative 6 and 1/4. Okay, so now I have my vertex. The vertex is at negative 1/2, negative 6 and 1/4. So you can't graph that exactly, but 1, 2, 3, 4, 5, 6. So negative 6 will be right here, and negative 1/2, negative 6 and 1/4 places it about there. Okay, now I also know that since a is positive, a is greater than 0, this is going to open upward. So I have my vertex here, and I know that this is going to open upward. And this is greater than or equal to, so I can use a solid line. Okay. Now, what we're looking for, if we go back and think about this, is times when f of x, or when y, is greater than or equal to 0. I can use a test point, or I can just use logic. I can look and see, okay, here at these x-intercepts, this is where y equals 0. Beyond that, up here, it was when y equals 0. Y equals 0 right here at x is negative 3, and y equals 0 at x is negative 2. Beyond this point, for x values over here and for x values over here, y is positive, y is greater than 0. So I can actually just look at this graph and say, okay, when x is less than or equal to negative 3, or when x is greater than or equal to 2, this inequality is satisfied. Now, So you can always look at it and do it by logic, or you can use a test point. So if I use a test point of 0, 0, what I would do is I would go back here and I would say, okay, I'm going to let x equal 0, and I'm going to see if that satisfies this inequality. So using my test point, and then I put it in. Now 0 squared plus 0 minus 6 is greater than or equal to 0. This gives me 0 minus 6 is greater than or equal to 0. Negative 6 is greater than or equal to 0. That is not true. No. Therefore, this is not part of the solution set. These values in here are not part of the solution set. So that tells me these are the correct values. And I knew that by logic, but you can always use a test point or verify using a test point. Therefore, my solutions for this inequality, for times when the function, or y, ends up being greater than or equal to 0, are at points when x is less than or equal to negative 3, or greater than or equal to negative 2. And you can see on the graph that that's true. When x is big over here, y is positive. When x is less than or equal to negative 3, y is also positive. Okay, first we're just asked to graph this inequality. And we're going to begin by graphing the corresponding quadratic equation, quadratic function, in order to find the boundary line for the solution. The corresponding function is y equals x squared plus 4. Okay, this gives me an equation with a vertex at 0, 4. So a vertex at 0, 4. Now let's find some points and then do the graphing. Okay, when x is negative 2, this gives me 4 plus 4, or 8. When x is negative 1, this is 1 plus 4 is 5. I already know that when x is 0, y is 4, because that is the vertex. And I know that this is a minimum because the parabola opens upward, because a is positive. So a is greater than 0. So this opens upward. And when x is 1, this is 1 plus 4, that gives me 5. And when x is 2, that's 4 plus 4, that gives me 8. Okay, so 2, 4, 6, 8. 2, 4, 6, 8. Let's start graphing, starting with the vertex at 0, 4. And I know this opens upward. And then when x is negative 1, y is 5. When x is negative 2, y is 8. When x is 1, y is 5. And when x is 2, y is 8. So I have, because this is a less than or equal to, I'm going to use a solid line for this parabola. And it's opening upward as I expected. Now, I graphed my corresponding quadratic function. I found this parabola. I graphed it, and now I need to use a test point. I'm going to use a test point of 0, 0 once again, because that's an easy point to use. And I'm going to go back here, and I'm going to say y is less than or equal to x squared plus 4. So 0 is less than or equal to 0 squared plus 4. 0 is less than or equal to 0 plus 4. 0 is less than or equal to 4. And this is true. Since this is true, the test point is part of the solution set, and this parabola divides this graph into two sections, the area within the parabola and the area outside the parabola. And since this is true, then my solution set lies out here. So again, very similar to graphing linear inequalities, where you find the boundary line by graphing the corresponding equation, and then use a test point to determine where the solution set is. Okay, now I'm asked to solve this quadratic inequality. I'm going to start out by finding the roots of the corresponding quadratic equation, x squared minus x minus 6 equals 0. This is also one that's most easily solved through factoring. And since this term is negative, I'm going to have x plus something and then x minus something. And I know that my factors of 6 are 1 and 6 and 2 and 3. and that I want these to sum up to negative 1. 1 and 6 are too far apart, so I look at 2 and 3, and if I added negative 3 plus 2, I would get negative 1. Therefore, this is x plus 2, x minus 3. And I can check that by saying, okay, that would give me negative 3x plus 2x, so my middle term would come out to negative x. Okay, and this equals 0. Using the zero product property, I get x plus 2 equals 0, and x minus 3 equals 0. So I solve and get x equals negative 2, and x equals 3. So my roots are right here, negative 2 and 3. Something else I know is that this is going to open upward because a is positive. And I'm going to go ahead and find the vertex. And that's negative b over 2a is the x value for the vertex. And that's going to give me negative, and b is negative 1, over 2, and a is 1. So that equals 1/2. So the vertex is at 1/2. Now to find the y value, the x point, the x value for the vertex, so x equals 1/2. Substitute that in to find y, the y point for the vertex. That gives me 1/2 squared minus 1/2 minus 6. This equals 1/4 minus 1/2 minus 6, which equals negative 1/2 minus 6. Oh, actually negative 1/4. 1/4, that would be minus 2/4, and that would give me negative 1/4. Minus 6 equals negative 6 1/4. Therefore, the vertex lies at 1/2, negative 6 1/4. Okay, so now I have the vertex, which is going to be down, right about down here. And I know that this opens upward. And I know that it's going to be a solid line because this is less than or equal to. Okay, now, what I want to know is, what are the situations when y, or this function, is less than or equal to 0? And I can actually just look on here and say, okay, y is less than or equal to 0 at all these values for x in here. So when x is less than or equal to 3, I see that y dips below, becomes negative, dips below 0. I could always use a test point. Test point of 0, 0. Substitute in 0 here. That would give me, if my test point is 0, 0, I'm going to get 0 squared minus 0 minus 6 is less than or equal to 0. Or negative 6 is less than or equal to 0. And that is true. Since that's true, this is part of the solution set. And the solution set is comprised of x is greater than or equal to negative 2 and x is less than or equal to 3. So that's going to give me x is greater than or equal to negative 2 and less than or equal to 3. So that's my solution for this quadratic inequality. Okay, now graph the inequality. First, graph the corresponding quadratic equation. And I have y equals x squared minus x minus 12. And I'm going to start out by finding the vertex at negative b over 2a, which equals, b is negative 1, so it's negative 1 over 2, a is 1. So that's going to give me 1/2. Okay, so the x value for the vertex is going to be 1/2. So what is y going to be? Y is going to be 1/2 squared minus 1/2 minus 12. So y equals negative 12 1/4. So 2, 4, 6, 8, 10, 12. So the vertex is going to be here at 1/2, which is going to be about here, all the way down here. And this parabola does open upward because a is positive. Now I'm going to go ahead and find some more points in addition to the vertex to graph. So when x is negative 2, if you figure this out, y ends up being negative 6. When x is negative 1, this is going to give me 1 plus 1, that's 2, so this will come out to negative 10. When x is 0, 0 and 0, that's going to give me negative 12. When x is 1, that's going to be 1 minus 1 is 0 minus 12, so it's going to be negative 12. When x is 2, that's going to be 4 minus 2 is 2 minus 12 is negative 10. Okay, graphing these. So this is negative 2 right here. When x is negative 2, y is negative 6. When x is negative 1, which is right about here, y is all the way down here at negative 10. When x is 1, y is down here at negative 12. Right about here. When x is 2, we get negative 10 right here. So I have a graph right here, and it's actually going to be a dashed line. This is going to give me a parabola that is a dashed line. Okay, because I have greater than. So my boundary line is not part of the solution set. So now I have this parabola, and I need to use a test point right here. Test point 0, 0. Substituting in here, that's going to give me 0 is greater than 0 squared minus 0 minus 12. 0 is greater than 0 minus 12. 0 is greater than negative 12. Okay, so is 0 greater than negative 12? Yes. Therefore, since 0 is greater than negative 12, this point would be part of the solution set. Okay. So the solution set's going to be in here. Again, we handled this much the way we would handle a linear inequality. And that is by graphing out the corresponding equation, y equals x squared minus x minus 12. And it gave me this parabola with a vertex way down here that's a minimum that opens upward. Then I went and found a test point, 0, 0, and I substituted this in and came up with 0 is greater than negative 12. And 0 actually is greater than negative 12. So this test point is part of the solution set, which would be right here within the parabola. Okay. Now, solve this quadratic inequality. First, I'm going to go ahead and find the roots, which are of the corresponding quadratic equation. And this is another one that I can do by factoring. I'm going to have x plus something, and I'm going to have x minus something. And I know that because I have a negative 10. So I'm going to have a positive and a negative. Now, the factors of 10 are 1 and 10, and 2 and 5. And I need something that is going to add up to 3x. And what would give me that is if I had a positive 5 and a negative 2. Because then I'm going to get minus 2x plus 5x to get 3x. Using the zero product property, I'll have x plus 5 equals 0, or x equals negative 5. X minus 2 equals 0, gives me x equals 2. So I have two roots that I found, and these are x equals negative 5 and x equals 2. So right here and right here. Now, I could find the vertex, and I have been finding it, but you actually don't need it for these. All you need to know is that this is, that the zeros are here, and this graph opens upward. So I'm just going to sketch this out. That this is a parabola that opens upward. And I don't know exactly where the vertex is. That's okay, because I'm honestly not concerned with that. What I am concerned with are these points right here. And I'm looking for values of x where this function would end up being greater than 0. So I'm going to look over here and see that whenever x is less than -5, y is greater than 0. Whenever x is greater than 2, y is also positive. I could also use my test point. And again, I use the origin as a test point as long as it's not too close to the boundary. So my test point is 0, 0. And I'm going to use the x value and put it in here and find that 0 squared plus 3 times 0 minus 10 is greater than 0. Let's see if that's true. 0 plus 0 minus 10 is greater than 0. Is -10 greater than 0? No. So this test point is not part of the solution set. The solution set is not in here. It's out here, just as I thought. So what this gives me is solution set where x is less than 5, or x less than -5, or x is greater than 2. So my solution set are values of x that are less than -5 or greater than 2. Okay. So that concludes this section of educator.com on quadratic inequalities, and I'll see you next lecture.